Alrighty, let's get started. Hello everyone, welcome back to this Learning Python from Scratch course, or webinar series, whatever you want to call it. This is the 10th day we're holding it, I do believe. So if you haven't seen any of the previous webinars, they are up on YouTube. If you are on YouTube, welcome. These webinars take place Monday to Friday at 1 o'clock UK time. So if you do want to join live, feel free. It is free, and you could ask questions, or you could ask questions, and I'll try my best to answer them. We have almost pretty much covered the procedural part of this course. We just have a few topics left, and soon we will be going to object-oriented programming. Yesterday's session we took a look at abstract data types and kind of discussed why they're important, and went through how we would do them in Python. I did give a challenge yesterday, so let's start sharing my screen. There we go, that should be fine. Let's just make sure the audio is set correctly. So, oh, there we go.
You couldn't hear me. Yeah, okay, so maybe now you could start hearing me. Didn't check that before we started, but thankfully I checked it now. So if you didn't hear me, hi everyone, my name is Amrit. Welcome back to this Learning Python from Scratch course. If this is day 10, so if you haven't seen any of the past webinars, they are up on YouTube. If you are on YouTube, feel free to join live. We host them Monday to Friday at 1 o'clock UK time. It is free. To get the link, it should be on our Facebook page. And if you do join in live, you can ask questions, and I will try my best to answer them. The audio should be okay now. Yeah, it should be okay now. So I don't know how much you heard of what I was saying earlier, but I'll go through the rest of it again. So yesterday we took a look at abstract data types, why we should use them, and how we would use them in Python. I did give you a challenge at the end of yesterday's session, and I did kind of give you a really complex example at the end of yesterday's session too. So I did kind of make a really complex version in front of everyone. So if you haven't seen yesterday's webinar, go check it out. It's on our YouTube channel, SB Components, and yeah. So yesterday, that's what we did, abstract data types. Today, we will be moving forward and going on to recursion. Today's challenge at the end of today's session is a very difficult challenge, but it should be good. It shouldn't take you too long, but it's not easy by any means. So let's take a look at yesterday's challenge and my code for it. So I did go through like 2 versions. I do have chat up, so if anyone is here and wants to ask questions, feel free to. Now, I did say that I won't be doing a basic version of this code. I'll be doing a fairly intermediate version, and I'll be showing you my version of that. So let's just keep it to the side, and we want the shell. Which one's the shell? That shell. And let's put the image back up. Cool. So let's scroll all the way to the top, and I have commented it, so it should be fairly straightforward. So it's a fairly straightforward program. You need to create a station record and make that into an abstract data type by putting in accessor methods, so getters and setters, and only using them in order to communicate with your record. We did go through why this is a good thing in yesterday's session, and do go watch it if you don't understand the point of any of this. We discussed all of that yesterday. So this is our, so the station record kind of needs to store the name, the operator, and whether it has step-free access. By operator, we mean what company kind of operates the station. So as you can see, we needed to know about 3 stations, Bristol, Reading, and York. I believe these two have step 3, Bristol doesn't, and anything else we need to say we don't know that station. So every station needs to obviously store 3 pieces of information, which is the name, operator, and step 3. So this is fairly straightforward. This is how you make our record. Of course, it's a class. We define its initialization. Remember, this is 2 underscores, not 1. That tells Python this is a special method. And you always need self. Python, when you do create a station, Python fills in self for you, but you still need it there. But anything else, Python, you need to give Python in order to create a station. So that's our record, fairly straightforward. And from yesterday's session, this also should be fairly straightforward. These are a getter and setter methods. So if you want to get information from a record, you just give it from a station or record, you just give it what station you want the relevant information for, and it will give it to you. Same thing for the setters, but instead of the setters, you have an extra field. Setters are basically if you want to change any of these values, you would use a setter. We don't really use setters in this code, but we still have them there, just in case we want to extend this and use them. Which is fairly straightforward. Now, I did split it up into 2 more methods. The first one is just a method that sets up an array that has our 3 stations in it. Creating the stations are fairly straightforward. I create the array down here, and then I immediately set up giving it the array called stations, and we just keep appending our new stations. So Bristol, Reading, and York, Great Western, Great Western, Great Eastern, false, true, true when it comes to if it has step-free access. So that's all the setup method does. It just looks a bit better than having it over here, just a bunch of lines over here. This just looks a lot neater. And the next section is it just prints out the information of a given station. So just if it has step-free access, or if this is true, print the corresponding message. Otherwise, of course, if it doesn't have step-free, it has to be false. There's no third option. So else print it in the relevant way. So that's another method I created. So just give it a station and it will print the relevant information for it. So of course we have our blank array, which is just going to store stations in it. We set it up, and I don't use a while loop, I use a for loop. So I set found to false. Reason being is if we haven't found a station in our array, we could just print out I don't know that station. But that's down here. That's after we've gone through the array and we haven't found anything. Because if we have found something, we then set it to true. We have found the station, print the info about the station, and break. So we'll get into this in a sec, but obviously this should be fairly straightforward. This is how you get information from the user, and we store it in a variable called user station. We then use a for loop. This is the method I taught at the end of our for loop session. This is just a really easy method to go through the elements of a for loop one by one, and each time set it to be I. So since we're just comparing it to the information within the record, if we get the name of station I, so whatever station we're on, and it's equal to whatever the user entered, of course we found the station, what they're looking for, we print its information, and we break out of this for loop. So this just prevents it. So if you created another Bristol station at the end here, without the break, it will print it out twice. So with the break, you only print out once. So you find the first station with the same name, print out its information, and you break, so you don't continue looking on through the rest of the array. If not found, then you print out the message saying that you haven't found it. So let's run this quickly. So let's run module. There we go. So let's do Bristol first. Bristol. There we go. Bristol is operated by Great Western and has no step-free access. Cool. Because it's false. That works. Let's run it one more time, but this time let's just type in some gibberish. So let's just say London. Oh, I know it's not gibberish, but we don't have a station called London. There we go. I do not know that station. If we do just enter in gibberish, there we go. Doesn't have that station. Let's run it one more time, and let's do the Great Eastern one to York. York is operated by Great Eastern and has step-free access. There we go. So it works. This is just to show you that it does work. And if you do not understand it, just go to previous webinars of the corresponding area to understand. So if you don't understand what we did in the for loop, if you go back to the for loop webinar, it should make better sense. If you don't understand the if statement, by the way, not just takes whatever found is and flips it. So if found is true, flop not just makes it false, and if found is false, not just makes it into true. So it just flips it, and even grammatically this makes sense. So if not found, do this. So not just flips whatever you give it. So if not found, just flips whatever found is. But hopefully that makes sense. And you can come into a live session and ask questions if you have any. So let's close this and let's get into today's topic. So I'm not entirely sure how long today's webinar will be. I have a set, I have one example to go through, which is a fairly basic example, and then I will give you the challenge. But that being said, the challenge does incorporate everything we've done so far, and would be considered fairly difficult by even university students. First, university students will definitely find it difficult. Second and third year, maybe not so much, but you only get better with practice. So let's get into the topic for today, which is recursion. Now, if you were to ask what recursion is, you would probably get an answer where along the lines of it's a technique that you use when a method calls itself. And what does that mean? Well, when you call a method, it's basically when you're using a method. So if we create a quick method called print name, and we give it a string, and then we could just say print hi. We need speech marks, and let's just say we print hi and then whatever their name is. So hi string. So this is our method, and to call the method, this is basically when you use it. So we print the name, and then we give it a string. So we give it my name. Whoops, not supposed to do that. Let's say we give it my name, Emre. So let's run this from module. Okay, let's save it, and there we go. Hi, Emre. So this is just where so calling a method basically means just using it. When you use a method, you're calling it. So here we're using the method, and this is where we're calling the method. That being said, recursion is when a method calls itself. Now this may be confusing into why it's remotely even used. What scenario would you use something like this? But you'd be surprised how often recursion is used. Now recursion has a benefit that it is simple, relatively speaking, to implement. But the downside is recursion could take up a lot of memory very quickly. So it's only recommended to use recursion when you're not going to call itself too many times. That being said, that's the downside to recursion. It could take up a lot of memory, and if your system is memory cautious, in the sense that you don't want to use too much memory, recursion probably isn't the best approach to code your program. And also using recursion could also lead you to create your own loops. So for today's challenge, we are not allowed to use loops. We have to use recursion. Recursion is technically part of functional programming, but of course it could also be done in procedural. Functional programming is just a method of programming where it's all based on functions. So there are different types of programming, like procedural programming, functional programming, object-oriented programming. Those are just three. There are more. That being said, let's get into recursion and how it will be used. Now, the most basic example of recursion is factorials. And if you don't know what a factorial is, let's do a comment. So if I say 5 factorial, it looks like that, 5 exclamation mark. In maths, the exclamation mark means factorial. And what this means is pretty simple, actually. It's 5 I don't have a times. There we go. 5 times 4 times 3 times 2 times 1. That's what factorial means. So if you say 10 factorial, that'll be 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. So from whatever factorial, so whatever number you give it, that number you keep minusing 1 each time. You keep timesing them. That is what factorial is. Now in programming, there is no function for factorial. I don't know why this just started running. Hopefully you can't hear it too much. Where is this off switch? Does it have an off switch? Okay, cool. Hopefully that turned it off. Sorry about that. Yeah, so in programming, I completely lost my train of thought. In programming, basic programs of Python, Java, all that type of stuff don't have factorial inbuilt into them. There are libraries you could import that will do it for you, but just a base version of Python or Java doesn't have it, not that I know of at least. Hence, today we're going to make our own version of a recursive method that calculates factorial. And there's two things to note with recursion. And the first thing is any recursive function or program can be written using loops and other stuff. It's always possible. It's you 100% can do it. So any recursive program can be written as in a procedural format, not using recursion, hence not taking up that much memory. That's just a fact. You could always do it. The second thing to note about recursion is that there's a recursive method requires two things, and let's get into that now. So let's call our recursive method, because we're going to be doing it for factorials, factorial. That's what we're going to be called, and we're going to give it a number. Actually, let's just say the number x. In maths we use x a lot, so let's just use x here. So if you want to calculate the factorial for x, here's what we're going to do. So every recursive method requires a minimum of two things. The first thing is a base case, and the second thing is a step case. So let's write that out. So we need a base case, and we need a step case. What does this mean? Well, a base case is something, once a certain minimum is met, you start exiting out your recursive program. We'll get into that in a second. The step case is, oh, I forgot a T. Step case. A step case is something that brings you closer to your base case. You could have many different step cases, that's fine. But generally speaking, you only have one base case, and your step case should bring you closer to your base case. That being said, for factorial, it's pretty easy what our base case is. Which way should I show you? I'll show you the base case. So the most basic version for factorial is saying that if x is equal to 1, return 1, or return x, whichever is fine. Otherwise, we don't care what the number is. Return factorial of x minus 1 times x. So this is our recursive method that calculates factorials. And let's kind of go through it, what it does. So assuming you give it a positive number, we're not dealing with factorials or negative numbers. That's a whole different ballgame. Assuming we're calculating factorials in positive numbers, this is going to work for the most part perfectly fine, unless also you give it a decimal number. This only works for whole numbers. And I think factorial also only works for whole numbers. I actually haven't played around with decimals and factorials. That being said, this is a base case. So if x becomes 1, we just return 1. Perfectly normal, nothing too fancy there. This is where recursion really comes into play. So if we don't have 1, what we then do is we calculate the factorial of the number below it, and we times it by x. So let's say we want to do 5 factorial. Let's kind of go through it. So you enter with 5. Well, 5 isn't equal to 1. So what you'll end up going to be doing is returning factorial of 4 times 5. And then when you enter with 4, what ends up doing is, well, 4 isn't equal to 1. So what you're going to end up returning is factorial of 3 times 4. So you go all the way down to 1, and then you go up the chain back to whatever number you started with. So just to show you that this works, I guess we could just immediately print the factorial of whatever number we want to calculate. Let's copy this just so I spell it correctly. Factorial. Let's first calculate the factorial of 1, which should be 1. Let's print a factorial of 3, which should be 6. It's just 3 times 2, which is 6, times 1, which is, of course, 6. And let's also calculate the factorial of 5. So 5 times 4 is 20, 20 times 3 is 60, 60 times 2 is 120. So that should give you 120. And as you can see, factorials become really big really quickly. There we go, 1, 6, 120, so this 100% works. So recursion is basically a method which that calls itself. That's recursion. And in recursion, the aim is that you're trying to get to a base case where you could figure out the rest of the program. This is a really basic example of recursion. There's only one base case, there's one step case, and is fairly straightforward. Also, just note again, it's recursion because we're calling the method within itself. It's still recursion if method A calls method B, which calls method A again. So if I were to do it as a comment, method A calls method B, so method A uses method B, which then calls method A. This is also recursion. Why? Because essentially a method is just a fancy way of simplifying code. But if you were to write it out long, if you like, you could technically get rid of method B in method A, and it will technically be that method A is calling method A. So when it comes to methods, this is also a form of recursion, since A is still technically calling A. So if a method calls another method, which calls the original method, this is also recursion. That may sound confusing, but people generally ask the question, is my code recursive? I take a look at it. Number 1, does it have loops? Nope. Number 2, does it then use functions to kind of do the challenge I'll give you today? And they say yes, well then it's recursive. So the entire point of recursion is it kind of does make it easy. If you were to do this with a loop, maybe you could do it in fewer lines, but recursion is very useful in things we will probably look into in future lessons. Probably when we start looking at data structures, you'll see a lot more use of recursion, but then we'll discuss, of course, the major downside, which is it uses a lot of memory, and then we'll look at other ways of going about it. So it should be fairly obvious that this can be written non-recursively. It won't be that hard, but it's always fun to use recursion, and it's also, in a weird way, satisfying to use recursion. But essentially, that's the basic idea. There's a base case. In this case, the base case is 1 because when you do 1 factorial, it's just 1 times 1. The entire idea of factorial is you get down to 1 and you times everything. Actually, just so everyone 100% understands, let's open up another whiteboard. Didn't really plan to do this like this. Was this the one I used? Yes, I do think so. Blank. There we go. So let's make this full screen. Cool. That should be a pen. Cool. So let's kind of explain recursion as it's happening in our factorial example. So let's say you want to do 5 factorial. I'm just going to call it F. for the factorial method we created, and we call 5f. At this point, I'm going to show it like this. So at this point, there's two things our program does. It first checks, is 5 equal to 1? Let's do 2 equal sign. This is wrong. So then what our program does, it does factorial of 4 times 5. This should make sense so far. This is what our program does. First it checks if f5 is equal to 1, which is wrong. I should probably like draw a box around this or something, which is wrong. Hence, it then calls factorial 4, so 1 minus 5, or 5 minus 1, times whatever your number currently was. Now at this point, our program does the exact same thing. It checks, is 4 equal to 1? This is also false, hence it does factorial of 4 times 3. Our program does the exact same thing again. No, sorry, factorial of 3 times 4. I just wrote it the wrong way around. Our program does the exact same thing. Is 3 equal to 1? No, it's not. So what our program does is factorial of 2 times 3. Can I scroll down? Is there a way of scrolling down? I could zoom out, I guess. This is slightly annoying. No, that's not what I want to do. What's this? Delete? Nope. Okay, never mind. It's fine. I'll just zoom out. And apparently it's not zooming out anymore. Cool. It's fine. We'll work around it. So at this point, it does the exact same thing. Is 2 equal to 1? No, it's not. So our program does factorial of 1 times 2. And at this point, our program does, is 1 equal to 1? Yes, it is. So now we start going backwards in our code. So we return 1. So we do 1 times 2, which is 3. Then we return 3 here. So we do 3 times 3, which is 9. So at this point, we then return this here. So 9 times 4 is, 9 4s are 36, which is fine. Then we do 36. Have I done a wrong calculation here? So 1 times 2 is 2. 2 times 3 is 6. 6 times 4 is 24. My bad. 6 times 4 is 24. 24 times 5 is 120. And that's what you return when you do factorial of 5. Hopefully this has made a little bit more sense, but the entire idea is you keep going down until you meet your base case, and then you keep going back up. If you think about it too much, you will also realize that this is highly inefficient, because if you want to use this factorial method again and again and again, it will cause it to then do these same calculations again and again and again. There is a way around this. We will look into that in the future, not for now. That's to do with other data types and data structures. So if we do cover that on this course later on, we'll talk about it then. But for now, that's recursion. And that's basically the gist of it. Just a method that calls itself. That's recursive. Needs a step case or multiple step cases, and it needs a base case. So your challenge, I know we're bringing out the challenge pretty early today. Your challenge is this. Now this by no means is easy. I will be going through my answer to this tomorrow. Tomorrow is Friday, so it will be the last lesson of the week. And by no means is this easy. This, a lot of people will struggle with this. But if you can complete this, you have 100% kind of mastered everything we've done so far. So the idea of this is you're kind of making a calculator that works in a very specific way and does very specific things. So now, by the way, you work in hexadecimal. So we're going to go through what hexadecimal is in a second. But you're working in hexadecimal. You don't need to go into 2 digits of hexadecimal, so don't worry too much about that. So you work in hex. Actually, we'll describe hexadecimal now. So essentially what hexadecimal is, it's base 16. When you say in maths base a number, that basically means what base you're working in. So computers work in binary, which is base 2. All computers to have are 2-digit zeros and ones. We work in base 10. We have 10 digits. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Those are 10 numbers. We work in base 10. In our day-to-day life. So when we do 12 plus 42, we're doing those calculations in base 10. Another thing computers use are base 16, which is called hexadecimal. And in hexadecimal, you need 16 digits. So what computer scientists just did is just slap on the alphabet to fill in for the rest of the numbers. So we have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, which is 10 digits. And then A, which is 11, 12, 13, 14, 15, and 16. So that's 16 digits, but their values are 10, 11, 12, 13, 14, 15. So 16 digits, but F has a value of 15. So A has a value of 10, B has a value of 11, C has a value of 12, D has a value of 13, E has a value of 14, F has a value of 15. Other than that, you don't need to know much more about hexadecimal, other than what the value of A, B, C, D, E, and F are. So yet again, A has a value of 10, up to F that has a value of 15. So what this calculator does is it works in this specific way. If you understand this notation, great. Otherwise, you could read this. So essentially, you have to give it a digit. So if you, so the program reads left to right. So in this expression, it will read left from here to right. So if the program sees a plus, all you're going to do is, so if the program sees a plus, it expects the next thing to be a digit being one of these things. It expects the next thing to be a digit, and then something else. It expects X amount of other things. So when the program sees this plus, it expects the next thing to be a digit, so one of these things, and an expression, so something over here. So some more values to its right. If the program sees an S, it just expects expression. So if you see an S, it just means that it needs more to its right in order to do it. And all S means is sum. So over here we were doing factorial in the sense that we're timesing, but this requires adding. So this should already kind of give you how the addition part will work here. Literally instead of a times, so it would just be a plus and maybe a different method name. And or it could just see a digit remaining. So if you just have F, it will give you the value of this expression is 15. Of course, S4 just means the sum of all the numbers till 4, which is 10. So here's where it gets a bit confusing. So S plus 2, 3 basically means the sum of plus 2, 3. Plus 2, 3 basically means add 2 to the next, add 2 to the next value, which is 5. So the sum of 5, which is 15. So 5 plus 4 plus 3 plus 2 plus 1. This is slightly more confusing. So the sum of all of this, first when you calculate all of this just means 2 plus the value of all of this. When you calculate this first, so this, so we're at this point, so plus, so 1 plus the value of this, and this of course just means the sum of 2. So 2 plus 1, which is 3. Then we add 1, so it's 4. Then we add 2, so it's 5, 6, and then the sum till 6, which is 21, and similar for that. Just do remember A, B, C, D, E, and F are all numbers in this scenario, representing 10, 11, 12, 13, 14, and 15 respectively. I will be giving my answer to this tomorrow, so do look out for that. I'm going to reiterate, this is not easy. If anything, this may actually take you a few hours to do. That being said, do give it a shot before tomorrow or before you watch the next webinar. If you're on YouTube, this by no means is easy. So don't be discouraged if you're not able to do this. This is a really difficult challenge. And the only rule with this is you can't use loops. So you can't use for loops and while loops, otherwise it won't really be a challenge. Just a few things you may want to know before attempting this. Just a few little things. Let's say you have a string. So we have a string called A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P. Let's just say that's our string. First bit of the alphabet. Now, if we do print, and this only works for strings, by the way. If you do print and the square brackets, well, you would remember these square brackets is to access a specific location in an array. But if you use it on strings, so let's say 3. Let's run this. Okay. If you use it on strings, it will give you that position letter. So A, B, C, D. So of course we want 3, so we start from 0. So 0, 1, 2, 3. Of course will give us D. If I did, let's say 0, this should give us A. Run. Okay. There we go. Give us A. So that's one thing you would need to know about this. It may help. It may not. Depends how you want to go about it. But this is really useful for know for this. This is how you access a specific letter in a string. You just specify what letter you want. If you go back to the image, this is the train one. We don't want that anymore. If you go back to the image, what else may you want to know? I can't think of anything else off the top of my head. The other thing was hex, but we kind of just talked about that. Yeah, that's pretty much it. So this may come in handy. So I've kind of given you this. If you're stuck at any other point, just use Google. Google will help you. And yeah, if you fully understand this notation, this may also be able to help you, but don't worry too much about that. And that's basically it for today. Today's point was just to teach recursion, its kind of benefits and drawbacks. Benefits being it could be simple to implement. Downside being it generally is very memory intensive, and if you care about memory in whatever program you're making, recursion is definitely not the way to go. So if you're creating a program for a microwave or a remote or like a device like that, you care about how much memory your code takes up and how much memory is available and all that type of stuff. So recursion is probably not the way to go for that. But it's a really good skill to know and learn and play around with. That being said, this has gone about for 40-ish minutes. So thank you everyone so much for watching. I'm going to leave the challenge up here for another few seconds. So thank you for watching. I don't see any questions in chat. So I will see you in tomorrow's webinar where I will discuss my answer to this recursive problem. And yeah, definitely give it a go. It's not easy by any means, but don't let this discourage you. A lot of uni students definitely find this very difficult. So thank you for watching. I'll see you tomorrow. Bye-bye.